This video is a demonstration and walk around of the Forest Manufacturing Model 2054 vertical blade traveling table bandsaw. I'm going to do two related videos. This is going to be a handheld walk around showing the various features and details of construction of the machine. I'll do a second video with the camera on a tripod where I'll do some demonstration cuts just to illustrate. We'll start off over here at the operator's panel. Most of the saw functions are controlled from here. You have start the saw blade motor, stop the saw blade motor, tension and detention. The blade all stops the table and the blade. The blade will stop automatically and the table will stop automatically if there's a fault with the blade. Table advance and return, table stop. Table advance is the forward or cutting direction. Table return brings it back to the home position, preparation for the next cut. Table return speed. We have two potentiometers, one for the advanced speed and one for the return speed. Return speed is here on the operator's panel because you're probably not going to mess with it much. You're just going to set it to full speed and leave it. Fault indicators, blade fault for either the table drive or the blade drive. Blade fault for the blade, either a lack of pressure or a broken blade. Motor fault, if you either the blade motor or the table drive motor has a problem, and toggle control the laser. Push once, turn it on, push again, turn it off. Inside here, fuse disconnect. This machine is wired for 460 volts, 3-phase. Control voltage transformer, stepping it down to 115, 120 volts, single phase. Some nicely done wiring here. The brains of the machine is a little PLC, really let's call it a smart relay. Gives us much more functionality than just a bunch of relays. Also gives us status inputs. The little LCD panel there illustrates all the status of all the inputs and outputs. Very handy for debugging if you should have a problem. Control relays. This is the table drive. The table drive is an inverter. Historically we use DC drive. We switched to AC, has a couple of advantages. The biggest is it gives us ramp speed control on the XL decel profiles. The way I have it set up now is it auto detects the amperage and uses the maximum acceleration or deceleration rate possible based on amp feedback. We have left to right here, disconnect for the inverter, separate fusing for the inverter, fusing for the high side of control voltage transformer, low side of control voltage transformer, and inputs and outputs of PLC. Magnetic starter with thermal overload for the blade drive motor, and terminal blocks for components outside of the control box here. Also comes with a e-stop mount on the stand. You can position that on the opposite side of the machine if you need to do a remote located e-stop. Around to the back side of the saw here. This saw, all of our 2054s really, come with a split flange feature. So this is a piloted, pin-piloted flange, allows you to remove the top half of the saw from the bottom. Saves money on transportation, particularly when these things get very tall. They can be a real bear to transport. Also, if you're going into a building with a low door height, it saves cutting a hole in the building. But because it's splitting the head, we have to disconnect the electrical. So we've got a little terminal box here with all the electrical items up on the upper part of the saw. This machine has pneumatic blade tension. Basic little mechanism there. Air cylinder on a pivoting tension arm controls blade tension. Air in provides with a speed decoupler. We have a pressure switch. This is set about 2 to 5 pounds. It's not meant to guarantee sufficient air pressure. What it's meant to do is make sure that the air line is plugged in at all. We don't want you to try and run this machine if the compressor was left off overnight or just the line disconnected. So it just determines you have a minimum necessary air pressure. Pressure regulator here. We have a dryer pressure regulator with valve. That's actually used to control the blade tension, and lubricator. 4-way solenoid valve. It has adjustable, these are adjustable flow control valves with mufflers. Then of course go into the blade tension cylinder. This is where we plug in the laser. The laser runs off 115, comes with its own little converter there, so we just provide a plug wired off the control panel. As long as I'm on the top part of the saw here. This is our crank style guide post socket. Loosen that up. Use it to adjust the blade guide position. This machine has roller blade guides. We have all the guards and such off right now just to make our life easier working around it. We're about to take it apart. The table drive mechanism. Table drive mechanism uses a tooth timing belt. This is a urethane timing belt with steel cords inside of it. It's proven very durable. The bandsaw environment is not the cleanest, and these timing belts seem to do very well in the environment. So you've got, this is your actual drive sprocket. Idler sprockets, loops around. Got these tail or return idler sprockets. They have tension adjusting screws. Not sure that shows up real well in there. Tension adjusting screws to set the belt tension. And because the belt is tensioning asymmetrically on this rail, we have these countering tension rods. So get the belt tension where you want, then counter the tension with these to straighten this rail, because this rail also serves as our guide rail. So if we put a lot of tension on it with this belt, but don't offset it, then we make a banana out of this rail, and you don't track straight. So that's just to make sure we track straight. Again, the guards are removed while we break this thing down. That's your AC motor. It's an inverter duty motor, rate of 6,000 RPM. The machine is designed to run at 1800 RPM, 60 Hertz. So you've got significant overcapacity if you want to increase the maximum table speed. The only thing is, over 60 Hertz, you go to constant power operation. So your AC motor, you can run it 6,000 RPM if you really need to move things quickly. You have a gearbox reduction, the chain reduction to get the final drive ratio, and then the two timing belt. Blade drive is pretty straightforward. This is a brake motor, 5 horsepower brake motor, spring set electromagnetic release. So if you have a power out or whatever, the machine will stop and the blade will stop quickly automatically. V-belt reduction to what we call the driving wheel. Oh yeah. Give a quick illustration here of how the tension mechanism works. Would you detension that, please? Thank you. Retension it. Good. And the blade tension controls are interlocked to the saw start, such that you cannot try and run the saw blade motor with the blade not properly tensioned. Don't think I've shown you this yet. So most of your controls are here on the panel face. They're duplicated on a handheld pendant. I've got this wrapped up to keep it from getting nasty out here in the shop. But you have left to right, saw start, saw stop, table forward, table reverse, table stop, and the laser button, the laser toggle. So these duplicate the controls on front. You can start the machine here, stop it at the control panel, or vice versa, turn the laser on here, turn it off the other side, however you want to operate. They are in parallel. The table speed advanced direction is controlled here at the end of the pendant. This potentiometer controls advanced speed only. The one on the panel face controls return speed only. The rationale there is the operator will probably want to control the advanced speed on the fly. That is, he can walk around the saw holding this pendant, start, stop the saw blade, the table, but also control the table speeds. For example, before he's cutting, when he wants to move the table up, such that the blade is right touching the workpiece, he can move it at full speed. Once he starts cutting, he can back that off and adjust that dynamically. Here's the laser mounted high. That comes off for shipping. We dismount that for shipping because otherwise they almost always get stolen. If there were somebody can reach them, they do get reached. This is the fence mechanism here. Aluminum faced fence. This is a pretty long span, so reinforced with a piece of channel, so it is that is stout. Uses a double gear reduction. You can see here on this side. This is what we call the operator side. The guide block uses linear slides. Those are not linear roller bearings, they're linear slides. It's a Teflon impregnated ceramic running on the usual steel rails. Gear rack, pinion driven, has a double reduction from the handle there. So you're nice and tight. On the opposite side, it floats. So we've got cam follower bearings, fixed high, and you can't see them, but below there are eccentric mounted cam followers to take the slack out. But this allows us for axial expansion and alignment. First off, it's just almost impossible to do structural steel like this and get it dead nuts aligned across this distance. This also allows for thermal expansion because I've got an aluminum fence face and a steel table. You can imagine what would happen if that was tried to fix rigid and we've had thermal expansion issues. So you can also see here that the gear rack runs both sides, so it synchronizes nicely. Turn the handle. This machine is equipped with our electronic digital readout. Programmable. Right now I had it set up to inches as a zero function. The zero setting is adjustable to account for the minimum distance from the fence face to the blade. The sensor is a magnetic sensor. You're seeing a stainless steel tape here. Underneath that is a magnetized strip. Very accurate. To open the fence, we're going to open the table for blade changes. Let's see here. This is our gate style. Takes a little bit of a pull, but that releases. And so it's kind of a piloted fit here. The idea is holds the width of the tables together and the spacing. I'm operating one-handed, so I'm not going to put it back right now. And I think that's all I need to show you on the walk around. Next I will turn this video off and set up for a demonstration cut. Thank you.